could have this whole inside, the whole inside the absolute value either could equal 4, or the whole inside could be -4, because then the absolute values would make it 4 anyways. So these are the two things that we have to check and solve. Well, how would I go about solving these? Couple of options. You could multiply everything out, combine like terms, and then factor. However, when you only have one thing squared, sometimes it's nice just to get that squared thing by itself and square root. So what would that look like? Well, if I move the 4 over, I'd get 0. If I divide it by the -3, I'd still get 0. If I square rooted both sides, I'd still get 0. And I get x equals 2. Do some quick mental math. I think this one's easy to do mental math. What's 2 minus 2? 0. 0 squared will be 0 times the -3 will be 0. You see you get 4 inside the absolute values. Does that equal 4? Yes. So this time I just did a quick mental math to check. What about the other side? Well, I'll do this in both techniques and you can decide which one you like better. So method 1, I'm just going to get my squared by itself. So I'm going to move the 4 over to the other side. It's going to give me -8. I am going to divide by -3. So that'll give me +8/3. I'm going to square root both sides. When you square root, you have to remember the plus or minus. And then I'm going to add 2. To both sides. And we get 2 plus or minus the square root of 8/3. Of course, an answer in this form wouldn't be allowed because you have a square root on the bottom of your fraction. So we would have to remember rationalizing the denominator. We have square root of 8 over square root of 3. This is a great review day. How do I get rid of the square root on the bottom? I'd have to multiply this by a square root of 3, which means I have to multiply the top by a square root of 3, which would leave me with x equals 2 plus or minus the square root of 24/3. But now we run into a secondary issue. This is not in lowest terms. The square root of 24 you can reduce because it's 4 times 6. So this will become x equals 2 plus or minus 2√6/3. And this is how the textbook has the answer at the bottom of the page. However, technically, this isn't simplified yet because you don't have a single fraction. The proper way as a single fraction would be to get a common denominator. So 2 I would write as 6/3. And this would be the right answer in lowest terms. Option 2 for the same question. We had -3, x minus 2 squared plus 4 equals to -4. You could multiply out your x minus 2 squared, which would give you x squared minus 4x plus 4. I'm going to just move this, combine those like terms. And now I want to solve a quadratic equation. So if I distribute, I'm going to get negative 3x squared plus 12x minus 12 plus the 8 minus 4 equals 0. Now, personally, if I wanted to try factoring this, and by the way, as we can see from the answer over there, it's not going to be factorable. I would probably move everything over to the right side. I just like my a value being positive. That being said, this doesn't work out. Oh, I forgot my little x. There we go. This can't be factored, so how would you solve something that can't be factored? Quadratic formula. So your x is going to equal negative b, which would be positive 12, plus or minus b squared, 144 minus 4 times a times c, which is 48, over 2 times a, which is 6. Okay? It's supposed to look the same as that other answer. Well, first of all, I'm going to do the subtract the 48 off there, and you see that you would get 96. And you'd have to simplify 96. Does anybody know that 96 happens to be 16 times 6? So then this becomes 12 plus or minus square root of 16 is 4 root 6 over 6. And because all the terms can be divided by 2, you would get 6 plus or minus 2 root 6 over 3. This would be a great exam question, because in the one exam question, I could test like 2 or 3 units in one question. Or this would be a terrible exam question. Some of you are like, I'm going to forget at least 3 of those 3 units if you give it to me all together. Sometimes it's better if you have the units in small little chunks, better. Because what did we have to know in this one? We had to know all of our solving quadratic equations unit. Either the squaring both sides or the quadratic formula. We had to remember our radicals unit on how to square root everything. And technically, we just did our new unit, which was absolute values and how to solve those. Questions to circle on this one are 11 and 12.